Good evening, this is Feras NASER, and today I'll be talking about deep learning applications in railways. The nature of this presentation is supposed to be technical, but also will introduce several business models and several new ideas that can be implemented in the railway context. So without further ado, and let us start. But before that, this presentation has been presented for the ICRI group, and I am grateful for this opportunity. We supposed to be in Istanbul for our conference, but because of COVID-19, we could not do that. So let me start the presentation. So deep learning in railway applications. This presentation is supposed to be to give you a good introduction of deep learning, but also supposed to give you a good introduction about new business models and new ideas that can be implemented in the railway context. The presentation outline will start with a quick introduction of deep learning. Then we'll be talking about computer vision and quick brief about computer vision, going to object detection and some of the models that I have applied for the railway context. Then I will be talking about railway applications. After that, I will be giving a quick brief about data and the current problem of data and its association with deep learning. Then we'll be jumping to natural language processing, talking about BERT and how this can be related to railways. Then we will be jumping to the future under the title A Leap to the Future, and we'll be doing some conclusions. Then I will be shed the light on few areas of collaboration that we can be working together. So let us start. So deep learning, what is deep learning? So deep learning is part of the broader family of machine learning methods and is based on artificial neural networks. And there is supervised, semi-supervised, and unsupervised learning. There are several architectures for deep learning. One of them is deep neural network, convolutional neural networks, recurrent neural networks, and many, many others. So the application of deep neural networks or deep learning has been applied to so many applications, including computer vision, speech and audio recognition, natural language processing, bioinformatics, material inspection, and broad board game programs like chess and Go, and you hear about AlphaGo, which has managed to beat the masters of Go game in the world. And this is showing you the current advances in artificial intelligence. My focus in this presentation will be on computer vision and natural language processing. To put this in a visually understandable manner, so deep learning has many applications, and you can see in the yellow boxes that the focus of the presentation will be on computer vision and on natural language processing. Of course, there is others, but we will not be talking about it. So computer vision has many problems, but one of the problems is object detection. And deep learning has proved to be a very powerful strategy for learning future representation. And there was a remarkable breakthrough in generic object detection. And what we mean by generic object detection, so please just have a look at the picture on the right side, and you can see these two welders and how the algorithm have identified there is a person one, person two, and there is a farther person at the end. But it has also identified that there could be a sink near the sleepers, which is a wrong identification, but it also identified the bucket on the left side. So what object detection models do, they detect several objects in an image and locate them and classify them, which is different than locating a specific object. So in a quick definition, so what's the objective of object detection? So this can be for any instance of any object for given categories to return a spatial location. So for given categories, you'll be giving certain categories for this object detection model to be detected within an image. And for that, in order for that to happen, you will be having several tasks that should be done. And some of these tasks are segmentation, scene understanding, object tracking, image captioning, event detection, and activity recognition. So, of course, there are many applications for computer vision and object detections, and this can be in robot vision, and how this is related to fully automated maintenance of railways, of course, consumer electronic security, autonomous driving, and this is, I guess, highly relevant to transport and railways, especially with maintenance equipment. So when you have an off-road equipment or a maintenance equipment or a tamping equipment, it's really good to provide an extra layer of vision to this equipment in order to either to apply its operation in a safer manner or in a higher quality manner, or to apply it within a multitask or do it within a multitask context. Also, there is human-computer interaction, and you can see many universities are doing tests online, and they are taking video footages of their students, content-based image retrieval, intelligence, video surveillance, and augmented reality. So there are a lot of applications, but I need to take this talk slowly to the railway application. So object detection can be either detection of a specific instance, for example, like just detecting fasteners, or detecting of broad categories, generic object detection. And we can see on the picture on the right side how the algorithm at the top detected the car, while the algorithm at the bottom had detected the car, the traffic light, the person, in the on the level crossing. So how detection happens? So in a simple way of saying that, detection can happen through a bounding box or through a segmentation mask. And the bounding box is this purple bounding box that is surrounding the car, and the segmentation mask is this blue kind of cloud around the car. So you try to mask every pixel that the object represent, that the image in the object represent, or the object in the image represent. So the research community is moving from impact level object classification, single object localization, generic object detection to pixel-wise object segmentation. The focus is on classification and detection. So classification is, there is a dog in the picture, there is a switch in the picture, there is a railway person in the picture, there is a defect in the picture, but the other one is about, and that defect is there. So you need to classify to find the dog, but you need to find also exactly where is that dog. And it's always a trade-off when you are applying these models. So it's a trade-off between accuracy and efficiency, and each one of them has its own challenges. There are, for example, in terms of accuracy, there is intra-class variations. There are many class variations, and then the images are not clear. And efficiency, there is a huge need for computational requirement and the number of objects that can be detected in an image, because there can be millions of objects and they can be only 10 or 20. So it depends on the efficiency that you would like to introduce to your algorithm or model. So let us talk about the architecture. So for a convolutional neural network, which is always or has been applied in so many contexts in the field of object detection, there is a hierarchical structure, and there is a number of layers. And these layers start with an input feature map, and there is a second, a 2D convolutional kernel, and you will be ending up with a pooling. So with a quick brief about this, you can see the input image at the top, then you can see that the image has been divided into several regions. Then it went into a convolutional neural network, which is actually detecting those features from the feature map. Then you have a pooling layer. And if we look at the pictures on the right side, you will see that this image is going through several layers, and in the end there is a loss layer and what can be called a ReLU function. And if you are applying this model in one of the new softwares like Feras or TensorFlow, things are becoming really easy. And each layer can be applied within one line of code. So for deep convolutional neural networks, there are several advantages, and one of the advantages is to be able to learn very complex functions and learning features with minimum domain knowledge. But there are some deficiencies. And let me talk about these deficiencies because they are highly associated with the application of of object detection models within the railway environment. The first challenge is label training data. So you really need a lot of label training data. The second aspect, you need considerable skill and experience for the person to be able to apply these models. However, this is getting less important because of auto machine learning or AutoML and hyperparameter. And there is a third issue, which is about explainability. How did the model manage to predict, or what, based on what factors or based on what kind of equation did the model predict the object, or to be able, the availability of the object within the image. So this, to be able to, the explainability of neural networks and deep neural networks is still an issue and is still a challenge. So now let us go to some of the models that is available in object detection. And object detection have been, object detection research have been going for a very long time, since 1999. But a great breakthrough happened in 2012 with AlexNet, which is basically was focusing on neural networks. Then several development happened with regional convolutional neural networks, then fast RCNN, then faster RCNN, and then we have ResNet and other, then mask RCNN, and recently YOLO and single shot detectors, and recently even CornerNet. So there is a continuous development, but the breakthrough happened in 2012, and there are many models, and these models are really, really promising. So the aim is to design, the aim for object detection is to design efficient and effective detector with small computational cost. You don't want to run your your program for maybe 3-4 days, but you really need a model that can work quickly, detect the objects quickly, but also detect them with high level of accuracy. So in the right hand side, you see that the ideal detector had high accuracy and high efficiency. Now, let us talk about the different types of detectors. So there is a two-stage detection frameworks, and there is one-stage detection framework. And for the two-stage detection framework, it has started with RCNN. There was further development with fast RCNN and faster RCNN, and then we had the mask RCNN. And I have applied mask RCNN in several railway environments just to try to see what the railway will be seeing, what the model will be seeing. And this is interesting. Let us see what kind of objects will be detected within a railway environment. And here we see some explanation of the object detection. And I want you to see that in this illustration, there is a focus on the several stages. So stage 1, region proposal computation, then stage 2, CNN model training and sign time. So it talks about how this framework is working on different stages. And this is why we call it two-stage or multi-stage detection framework. And on the right side, you can see that the development is happening from RCNN to fast RCNN to faster RCNN, and even more models are coming. Now let us talk about single-stage detectors. It has started with a model called overfeed. Then further models were developed, including YOLO. YOLOs were very famous models and made a big fuss, and there was in the internet. So basically, a PhD student at the University of Washington has built this model, and it was a phenomenal success. So in the beginning, it was fast by design, that it was running by 45 frames per second. Then it has even, they developed a new version of the model that is called Fast YOLO or YOLO 9000. I'm not confident of the name, but has achieved 155 frames per second. Now, for the single shot detectors, which is another type of one-stage detectors, single-stage detectors, it has achieved 74.3% of mean average precision. And this is a metric for the accuracy of detection, while frame per second is a detection for the speed of the detection. And that happened at 59 frames per second. So it has managed to beat models like YOLO 45 and RCNN in terms of quality and in terms of speed. And there is a new model that is CornerNet. Our focus on this talk that I have applied YOLO, SSD, and mask RCNN on different railway environments to give a feel for future researchers or current university researchers or the people who are working in the industry of what does these models see and how we can improve them to the interest of the railway industry. So this is the model of overfeed, and you can see on the right-hand side how the models are developing between mask RCNN, then you have YOLO and SSD. And let me talk a little bit about performance metrics. So there is a detection speed, which is about frames per second, and there is precision, which is about average precision and recall. And based on that, the quality of the model is determined. Now, let me talk a little bit about some of the railway applications, and this is a very interesting part. So where did computer vision has been implemented, and what was the focus? So one of the areas of focus was on fastener inspection. So you have a high quality camera that is taking continuous images of fasteners and trying to detect the defects. There was a focus on obstacle detection. Another area of application was daily entrance and exit of passenger flow of railway stations, rail surface defects, and sometimes satellite and unmanned aerial vehicle images analysis. And I wanted to have a feeling on what does a generic object detection algorithm see in different railway environments. So I decided to apply YOLO, SSD, and mask RCNN. You can always watch the video on the YouTube link, and it's fun to watch. We have added some music to this video to make it as interesting as possible, but it's also fun in its own nature, seeing this model detecting different objects in the railway. And I really encourage you to forward this video to your colleagues so they can really have an understanding of what is the available technology today, and to try to think of potential solutions and potential ideas and potential innovators that can help them in their daily work. We don't know where innovation can happen from, but I know for sure that if people know that the technology exists, and if people know that there is something that can be helpful in detecting objects, maybe they can come up with good ideas, and innovation will foster and prosper. So this is the three models. So we have a single shot detector at the top left, then we have YOLO, and we have mask RCNN. We can see that the single shot detector detected the car, then there is detected a person at the end, and on the YOLO you can see that it has detected the car. This is of course from different frames of the video, but I want to show you that actually the three models can detect different objects. And for the mask RCNN, you can see that it has detected the traffic light, the car, the person, and then there is the car inside the garage or the farther car. So there is something that I just want to tell you to try to differentiate between mask RCNN or YOLO and SSD. So how mask RCNN detect an object is by putting a mask on the image. So you can, or on the object, so you can know exactly where is that object, while YOLO or SSD is focusing on putting a bounding box. So let us apply this on a level crossing, and I am confident that this is even better than the ability of a human being. These models detect these objects in a fraction of a second. So if I ask you how many persons in the image on the left, you might be spending some time counting, maybe 2 or 3 seconds counting people. And but the model actually managed to detect them to detect most of them, or not, if not all of them, in a fraction of a second. And then you have the object, then you have the pictures on the right, and you can see the model how detected motorcycles and people. So let us go even to other areas of application. So we can even apply such models in railway stations. So you can see on the model on the left how the model actually not only detected the people, but it has detected that this is a person, and the blue color showing this is a suitcase. So it has detected this is a person, this is a suitcase. So it gives a new way of looking at objects within a picture, but of course it did not detect, for example, the clock, it did not detect the flag, and so on. So there is a limited number of the things that it can be detected. And now, the picture on the left, you can see that several people are being detected in front of a ticket barrier. Now, you can also apply this in different railway contexts. So let us see if we can apply this in the maintenance environment. So we can see on the right-hand side that these three workers working with this equipment, and the model have managed to detect that there are 4 persons and there is a traffic line, and has wrongly detected a skateboard on the right-hand side. And with that, with the left-hand picture, you can see there is a picture, and there is also detected an object on the left, which is also not an accurate detection. But the models in general are very accurate in detecting people, but they are not very much accurate in detecting objects that is related to the railway environment. And here you can see the model is detecting the switch and saying it's a boat, and inside of a tunnel. That was really my original aim. I was hoping that I would be able to detect welds or welds failures from a camera inside the tunnel. That was a far reach or a very difficult task. So I decided to try to detect. Just to try to apply the model, and I discovered that the model defined each rail as a bottle. So that's a wrong detection. Please go and watch the video on our YouTube channel so you can actually have a good feeling of what the model can detect, and maybe you can have some good ideas on where it can be applied. Another example is these 2 welders. And I have talked about this example in the beginning. So the model has detected 3 persons, then it detected a sleeper, and it has said that it's a sink. So this is because the model is not trained to detect sleepers. So he thinks that the shape of these 2 sleepers looks like a sink, which is to a certain extent it can be a sink, but it's not within the railway context. This is why we need deep learning models that is being trained on railway data. Now, this is the golden opportunity. And now this is the previous work was my work. Now I will just be talking about a golden opportunity. So now during COVID-19, many transits stopped operating, or they were operating in less than their full capacity. And every railway company CEO was thinking how I can run my operation safely during COVID-19, how I can make sure that my infrastructure is not transmitting the disease or the virus, how I can make sure that people are safe within my railway environment from a health perspective. And a lot of people was talking about the compulsory usage of masks. And then I thought maybe you can add actually an additional layer before the ticket barriers based on computer vision, where the person just comes and show his face to the camera, and the camera detects if there is a mask or not. And if there is a mask, the first gates open, and then he can put his ticket on the ticket barrier and enter to the trains. So I think this kind of control measure will be effective in trying to make railway operations safer during COVID-19. And there is a lot of funding for that. So when you look at how much funding has been allocated to try to contain the coronavirus crisis, you can see some of it was allocated for transport. And for that reason, I think it was fundamentally important that we really think about this solution. And I think this can be a golden opportunity. And I know in some, I heard in the news, there is a metro in France, a station in France that started applying or started a trial for this kind of technology. And I think this is a golden opportunity. This is the right time to try to seize this opportunity. But so there is a difference in terms of should we have compulsory masks or not. So I don't know if you should wear masks whenever you are outside, but what I think the figures are showing and the numbers are showing that the countries that have used masks in general have decreased the spread of the virus. So we do not want to spread, we do not want just to try to force people to do things that they don't like, but what I would like to focus on is to make sure that we have the control measures for the next pandemic and for the next wave of virus. So I think once I hear Bill Gates saying that we don't have the systems in place that can help us to overcome the next pandemic or the next virus, and I think he's right. So if we don't have these systems in place, just in case of emergency, just in case if we really want to apply them, I think we are really missing something in our safety guidelines, in our procedures on how to run operations during a pandemic, how to run a railway operations, how to run a metro operation during a pandemic. So, but also this is not the whole story. So let me tell you about some of the challenges. And this is Andrew Ng's work. And Andrew Ng is one of the pioneers of deep learning. He's an absolute legend. It's a phenomenon. This is the kind of guy that is applying deep learning models for most of his life. And you can go to deeplearning.ai, to Coursera, and see some of the works that he has done in the area of deep learning. He is talking about that there are several challenges that is facing deep learning at the moment. The first one is small data, and we have this problem in the railway. So you have small data about defects, and it also it talks about data distribution. So having 1,000 images of fasteners or defects in fasteners, and maybe 1 or 2 images of the defect in the frog of a switch will not be helping an object detection or a computer vision algorithm to detect that fault. And he's actually talking about some of the promises that you can actually generate images. So you can have 100 images and make sure that you can generate thousands and thousands of copies of replicate images. And he says this is a very powerful training approach and very powerful training strategies. Which also he talks about generalization and robustness of production systems. So he says some models that works very well according to a published paper sometimes do not work in a production setting. And there are some solutions for that. So we can have humans in the loop, and we can also have some technical solutions. And I personally believe that this decade, 2020 to 2030, will be the decade, the human in the loop decade. That's my own opinion, in order to have these systems working and their system. And we have actually done early ideas on trying to bring the human in the loop, whether it was with our solution inspector or with Wish's point. We thought that a human in the loop can assist in verifying the data and making sure that you have a more robust prediction. But there is a huge, and the third thing he talks about, of course, he talks about that there is a huge gap between machine learning model and machine learning system, but there is also a challenge in terms of change management. Informing people about deep learning, informing people that these models are coming to help us rather than to take over our jobs is becoming challenging a day after another. So you need really a very strong change management practices and to make sure that the management is taking this approach by informing the employees or by informing the team that these systems will be working as an asset for the individual and the organization at the same time. And this is Andrew Ng's illustration that the AI model at the center of a production ML system is only a small part. So there are other, and he's taking this from the healthcare. So you can say there is disease data analytics, data verification, efficient batch data labeling, and other parts that makes a machine learning system works in production. Some of other works, some of the interesting works that applied computer vision to the railway environment is a study by SPP and CSEM. So they wanted to try to classify railway surface defects. So of course, this is not a generic railway environment object detection. This is not the kind of approach that I'm talking about, that you really need to detect general objects within the railway environment. So they actually, they were focusing on surface defect detection. So they had, so the challenge they went through that they had very little training data, and the fault categories, they reduced them from 20 to 4. And they say that expert opinions about surface detection, surface defects can vary. So this actually resulted in the following. So they had great results in terms of detecting joint, having 57% success in terms of detecting wells, and 65% in terms of surface defect, so detecting other types of defects. And they had no training data for squats and wheel slip. So I don't think this is an acceptable in a railway context, but it's a good result. It's a good result that a model that is able to do that, that is a computer vision model is able to do that. But we want something that is useful, that can really help us in our daily operations. So there are continuation for this research, and what we need is something that can help us to pave the way for more automated maintenance that we can rely on. So 57% of well detection is not a result that we can really rely on, because definitely any patroller can detect wells in better than the existence of wells better than 57%. So the human eye is much superior than this by far. Now, in another study that was focused on rolling contact fatigue, it was concluded that the investigation of API images of the rolling surface on a crossing nose during a frog's life cycle has shown that they have a significant statistical relation to the frog's lifetime. What I need to focus on is the relation. So if we have managed to detect objects within a picture or within the railway context, maybe within a short period of time, we are able to detect even the relations between these objects, how these defects develop, or how things change over time, or how usually if you have one defect, there must be another defect nearby. So this will pave the way for more interesting research by first detecting the object, then maybe you will be able in the future to detect the relationship between these different objects. There was another study that was focusing on welding. The proposed method was successfully, so it's saying that the proposed method successfully identified the weld bead edges with maximum errors of 10.26 pixels. So this is not a generic object detection, but I think this is why object detection will help in various aspects. Now, for us, for me personally, as Feras NASER, and transport men, and our focus on bringing innovations in transport and innovations in general, we have developed a solution called Inspectro. And this solution, Inspectro, has actually helped in, it was a handheld device that you should be giving it to your patrollers, and it will give them inspection instructions. So they will go and inspect the switch. So it will ask them, was there some cracks on the nose? How did you check can you take an image of the check rail, and so on. And this process, usually not a lot of people memorize it by heart, and there are a standard procedure. In addition to that, while the device will be asking you and you will be answering him, and your answers will be recorded as a text, and you will be able to take images. This actually helped in bringing much more data and more interesting data from the railway environment that is specific, that is focused, that is linked to text, that is labeled, and it can also help in having this handheld device that is being used across so many organizations that can help in the object of having, in the objective of having generic object detections. So if railways will move to the world of AI, they have really to invest in deep learning, computer vision, and object detection. And I think why this solution sounds not that great and it's dependent on human intervention and so on, I think it gives you this good collection of data that can help you in developing generic object detections in the railway environment. So what was my contribution in this area? So, and for this presentation, because I always like to be beneficial. I always like that you spend some time and you got this from my learning. So the first thing you got there was an introduction of several generic object detection models, and I have applied them to the railway environment, and you can always go to the YouTube channel and enjoy watching that video. But you can also have a look at our inspector, or the handheld device that is working as a data collection platform. And also we have identified a golden opportunity during COVID-19 of mask detection. So this thing can be applied quickly. This thing can be helpful in promoting computer vision and object detection research and other deep learning work in the railway environment, and this will definitely result in successes in several areas. And on this, more on this, I'll be talking about. So let me give you, now let us move to the data, talk a little bit about the data. So deep learning has shown the need for labeled data in order for models to work to an acceptable level of accuracy. So there was a great breakthrough in deep learning. And if we invest in deep learning and if we have the right labeled data, then we might have new areas of research emerging, including privacy, ethics, policy, new deep learning models, prediction learning systems, and more. So the old perception that the railways already have enough data and they don't need more data. And I believe there is a great amount of data, and some of the current deep learning models will help in analyzing all data. But also I think there is an emergent need for more comprehensive, smart, innovative, and labeled data collection tools that people will find interesting value in these tools. So it is something that you can use across so many platforms. So that was the data bar. So let us move a little bit to the world of natural language processing and how we can utilize the recent advancement in natural language processing to advance some of the railway aspects. So the subfield of natural language processing is about linguistics, computer science, information engineering, and artificial intelligence, and it's concerned with the interaction between computer and human natural languages. So I did not go to a comprehensive literature view of the latest advancement of natural language processing, but there is a new model that is called BERT. And BERT is an acronym for bidirectional encodable representations from transformers. Not to be bothered much about that, but what you really need to be knowing that BERT is the state-of-art kind of model or technique, model that has achieved an outstanding results. It was trained on a book corpus, which was 800 million words, and the English Wikipedia, 2.5 billion words. And it has achieved the state-of-art performance based on GLUE, SQUAD, and SWAG for some time. Now there are new models, but they are somehow dependent on BERT. And these kind of benchmarks measure new models in natural language processing and how this can actually happen, how this can actually push. So they do different tests on different models. So some of this related to grammar, some of them related to reasoning, some of so different testing strategies, and they rank these models based on performance. So the SQUAD, which is Stanford question answering data set, will be very interesting. So this is the SQUAD. You will be having a paragraph, and this is a paragraph about computational complexity theory, and you just need to ask a question. So the question, what branch of theoretical computer science deals with broadly classifying computational problems by difficulty and class of relationship? So that's the long question. And the ground truth answer, so the right answer, based on the text, is computational complexity. And the prediction of the model, so if you apply this model and you just throw this question to him, to consider this as a search engine, the prediction would be computational complexity theory, which is very much right. So now, BERT is very much able to understand very large texts and to find answers for questions within these large texts. So is this helpful for the railways? How is this even helpful for the railways? So this is a very nice story. So recently, there was a group of researchers shared 2 paragraphs about broken rail derailments per broken rail. This is the figure in the left, and you can see that they are peaking in the month of May, June, and July. But it has also shared a broken rail based on and broken rail derailments percentage, and it has linked that with broken rail derailments per broken rail with the months. And you can see 2 peaks. One is happening around October, and one is happening in the summer. And they throw a question, and the question is, so I would be grateful to receive any hypothesis to help explain why the ratio of broken rail derailments, broken rail is generally greatest in the summer. So he's asking for a question for this answer. And the second question, and why the same ratio, but for contact stress related breaks and derailments gives summer and fall peaks. So this is the diagram at the right hand side. So he threw these questions, and an email thread started, and with that email thread, people started answering based on their experience. So the answers came from different perspectives. So people talked about vehicle dynamics and wheel rail forces. They talked about temperature rail, critical crack size, rolling contact fatigue loading, tensile stress, and many other parameters. Some people talked about wheel rail surface interface, like adhesion. Others talked about vibrations. The signaling system did not detect the broken rail, and many others. But of course, for sure, not all of these answers will be right. Not all of these answers will be the scientific answer. They can be opinion, but we need to have a scientific answer that we can rely on. So an answer came, there may be a certain type of fracture, the formation of which and growth are less temperature sensitive. We know that defects in the transverse plane are negatively impacted by falling temperature, but those don't compromise all of the fracture. So this actually sounded like a reasonable answer, not linking fractures or the broken rail only with temperature or only with summer and month. So, but I wanted to do this kind of wicked experiment. So I wanted to write the answers of the people. So this is person 1. He has given these answers, and I wanted to, from his paragraph, from his answers, I want to try to identify and label different words within answers. So this is a parameter, this is a conclusion, this is a fact, and to try to see if this can, so if this can work within a natural language processing model. Of course, I did not apply this, but I built a table. So the opportunity here is that actually we can run BERT, and while we can correcting these answers about expert knowledge and expert opinion search, and we can build this search engine for the railway where people can just enter their answers to different questions, then you will be having the rail breaks, for example, like the rail breaks in the thread or surveys, or our solution in Spectro, where people just answering questions during their handheld device and while they are on site, and while they are taking pictures, and while they can even assist the answers with further on-site information. From all of these texts, from all of these information that is being gathered and that is being gathered around, you will be able to apply BERT, which will be helping answering new questions. So why this is happening, why there is a fracture, and you will be getting scientific answers from expert opinion. And I think this is fundamental for preserving the railway knowledge and the railway experience, because a great part of that is based on experience, great part of that is based on research, and we really need to transfer this knowledge to the next generation. But it also might help in actually future development of some areas of research. So again, that's InSpectro, and I hope that you got it in the right way. So InSpectro is a handheld, a voice-enabled device that was aimed at helping in visual inspection. You can watch a video of InSpectro on my YouTube channel, which will be also a very, very interesting video, because you will be seeing me experimenting with this device inside Marmaray Tunnel. It wasn't just a prototype, a kind of just to demonstrate the concept, but it gives you a good illustration of what are the possibilities of this device. I have published a paper about, also you can read my paper, which is about the potential use of blockchain technology in railway applications and instruction of mobility and speech recognition prototype. And this is important, because a lot of people are concerned about privacy. A lot of people think about decentralization is the solution. And I talk in this paper about the adoption rate of the technology. And I think I am reasonably right about adoption rate, and among many other things, but I would advise you just to go maybe and have a look at my paper, or have a look at the video, and this might give you a good introduction of what area, how we can use new ways of data collection to build generic object detection and to feed our new developed deep learning models. Now, let us jump to the future and talk about the future of railways. And this is a very strong vision of mine, which I think is really needed in our current time. So in 2008, I have made a presentation in Jordan Engineering Associations talking about that railway stations will be the next Facebook. And what I meant by that, there are a lot of data that is being collected at railway stations, from CCTV cameras, from ticketing, from ticket barriers, and maybe from mobile apps and so on. And this data can tell a lot about the individual and can tell a lot about individual behavior. And in 2018, I went to the States, late December, early 2019, Jan 2019, and proposed that the use of trust services as a new service that is offered by public infrastructure agencies. So if you want to make a new railway project, funding is always a challenge. But how you can justify the building of a railway project in a new way, because you should be able to utilize the data and leverage the data that you have been collecting in several parts. And this can be trust services. And what trust services, I don't mean security services, I mean kind of a trust score that you can say this person is trustworthy, let's do business with him right away without the hassle of knowing him for 2, 3, 4, 5 years. I think trust, having a technology of trust where you can just switch a button and can tell you this is a trustworthy person, this is not a trustworthy person, and to a certain degree it can be accurate, will fundamentally change the way we do business, the way we interact socially, and the way we become together as human beings. Because we are much siloed in identities that was built over years and years and years. So I think this is a golden opportunity. So let me just talk about this opportunity in a clear way. And this is the third opportunity. We talked about the mask detection. We talked about BERT and applying this for expert knowledge research. And now I'm talking about using railway data for trust services. And this is the three opportunities that you really need to remember from this presentation. So utilizing the data that is available about people in railway stations and in railway trains, specifically during long journeys, can help in the following. Building a better understanding of the concept of trust. We don't know how far we will be reaching, but we will be definitely having some understanding of people behavior. Offering trust services, which can facilitate social and economical interactions. And people will have difficulty objecting the use of data. And this is an opportunity we don't have. We have over smartphones, or we have over other kind of technology, because it happens in public space. So you can't say what you have done is private because you are doing it openly, you are doing it on the train, you are doing it on the, so you are doing it on the train, you are doing it on railways, inside the railway station. So definitely people will find difficulty objecting the privacy part. So this can facilitate many others area of research in social science, engineering, and more. Trust were broken trust were in crisis during COVID-19, that's for sure. Now, few remaining advantages for the rail. I want to talk about what is remaining for the railway as a transport mode. So friction is one of the key advantages of railways. The wheel rail interface is still an interface that has very low friction in comparison with tire and tarmac. So we are still having lower friction, and for that we have lower environmental impact. Speed for high-speed rails is another advantage, and space. We do not really need a huge space in comparisons with roads and so on. But of course they're passenger. But the development of electric autonomous cars will lead to the development of electric autonomous buses and electric autonomous trucks and so on. And many advantages of the rail will fade, that's for sure. And so, for example, today there is 1 million Tesla cars running in the world, and they are electric and they are semi-autonomous, and in the future might be autonomous. They are already running all around the world. And this is leading me from whom we can learn. So I talk about Tesla, and this is related to using computer vision in transport. And I talked about Google, and this is about using deep learning models and machine learning and privacy. So for Tesla, they have built a production machine learning system in real transport scenarios. So the car is doing navigation by being dependent on cameras. So the Tesla autopilot model. But in order for them to do this, they are actually going through several steps. So in the beginning, there is an approximate object detector, and this actually detects the objects. But whatever the model is detecting, there is an algorithm and sensor health monitoring that detects the health of the sensor and the health of the algorithm. Is it detecting the right objects? Is it getting this accurate or not? After the model detects different objects, they go into a data engine, and some engineers label the images in an automated way. So there is a system that is designed to label these images in a quick and autonomous way, and automatic way. And then they do try to test the new developed machine learning models through an evaluation metrics, knowing about their accuracy and their performance during several scenarios. So now they have HydraNet, which have a shared backbone with more than 1,000 detectors. Those are 1,000 testing detectors that is working over 48 networks, and it uses 70,000 GPU hours. So this is a lot. But what we can learn from that, Tesla has actually gone through the process of knowing how to use deep learning in real-time transport scenarios, and this is the key takeaways. You can look at this is the Tesla AI director. I think his name is Andre, and I'm just referencing his work, and you can see that what kind of steps they have taken to bring deep learning and artificial intelligence model to real transport scenarios. So of course we can learn from the current development in Tesla. So the other company that we can learn from is Google. So Google is really the pioneers of making machine learning as accessible as possible. So we are talking about TensorFlow, we are talking about Feras, which made applying machine learning as easy as a breeze, or maybe 56% or 70% of the models development in Kaggle competitions are based on Keras. So definitely Google has managed to help in spreading deep learning applications and deep learning models across the world. And also they have a TensorFlow for mobile and TensorFlow for JavaScript to try to apply these models in a mobile app or in a web application. But it's not only about machine learning. This is about developing personalized and on-device training. They are focusing on privacy-preserving machine learning systems. And when I was in Seattle, I was introduced to the concept of federated learning. So this is about having on-device training instead of sharing your data to the cloud, and the training happens in the cloud. So it's about having a group of machine learning models that is being aggregated and sent to the cloud without compromising the individual privacy. And recently there was a new publication by MIT about split learning, which is kind of more efficient federated learning approach. So remember please remember those algorithms that we talked about, object detection, and how different developments led to even further development. And so maybe we just talk about, we always need to think about what is the railway data engine. And this is a question you might ask for someone like Clive Roberts, and he will say the railway data engine is the onboard train sensors. And maybe people will think it's stations and train CCTV cameras. And maybe others will say it's handheld devices used by people on a daily operations or by operation staff for maintenance and operation, of course. So I don't have a clear answer, but I think they all complement each other. But what I know for sure that there is a need for a more of a generic kind of image detection within the railway context in order to help in improving the algorithm models and so on. And this can happen through a handheld device, but also it can happen through even more advanced ways, through this helmet. So there is a company called ICRI, and we talked with them around 2006, and we told them maybe we can really apply in Spectro on their helmet. So instead of listening to the instruction using the smartphone, you actually listen to the instructions using the helmet and using the headphone, and this will actually help in making a more user-friendly kind of machine-computer interaction, machine-human interaction, and maybe this also will provide an augmented layer that people will find it interesting and useful during their maintenance routines or during their daily operations. Now, and this is the important part for me, which is about collaboration. And this is really fundamentally important. And this is why I really wanted to come to Istanbul, and I really wanted to see you guys. I really wanted to have some new areas of collaboration that we can be working on, and we try to advance the technology and the railway field forward. So, but before I talk about collaboration, let me give you a quick brief of what we have done in this presentation. So we have presented an introduction to deep learning, computer vision, and object detection. We have made a video testing 3 generic object detection models, YOLO, SSD, and MASK-RCNN. And this just to give you a feeling of what these models can detect in a railway context. And you can always go to my YouTube channel and watch this video and enjoy it. And I assure you, you will like seeing the video. We talked briefly about the data challenge, and we made a quick introduction to NLP and PERT and how PERT can help in collecting expert opinion and having this knowledge index for railways. We have also identified 3 key opportunities, quick wins for the rail industry based on the available technology. We talked about mask detection during COVID-19 crisis. We talked about PERT and using this for collecting expert opinions. And we talked about using railway stations and on information from trains to offer trust services. And the last part, we have introduced my work in Spectro, which was a new data collection tool that has the possibility of applying such a solution on augmented reality helmets and more. And we talked about my opinion about the future of railways and what is the railway data engine. So that's what was the presentation. So let us focus on where we can collaborate. And this is few quick takeaways. Maybe we can collaborate in this area. I'm open to new ideas, but I think this is quickly understood from this presentation. So I'm very happy to write a specific proposal for an R&D grant based on the previous golden opportunities, but we would like to apply for grants with high possibility of success. So that's the first one, the first area of collaboration. So specific proposal for an R&D grant. So also we do welcome offers for early market representation or technical follow-up. So if you have a product or if you have a technology that you would like to introduce to certain markets, we are happy to collaborate with you and to introduce these markets to as part of our transportment.com startup, which we try to bring different people working in the transport organization and the recent advances in transport technology to life. But also we also consider this location to become nearer to Asia. Now I am based in Amman, but I think it's good to be nearer to Asia because there is a lot of advances happening in several areas, in 5G and in high-speed rail and even in transit. And it could be useful that if I move closer to Asia. So how I will be doing that, there was a new offer from a university called SP Jain, and they wanted me to do a general MPA. So I'm not sure, but they say you do part of it in Singapore, part of it in Sydney, but this is really closer to Asia. So I did not take my decision, but if there is a welcome, I welcome offers to co-sponsor the scholarship to cover additional fees. And for that, we'll provide new rail-related business models and systems as an exchange of this sponsorship. We can talk about this more if you are really interested in co-sponsoring this opportunity. Also, I'm not sure if I will do this, but that's one way of doing this, and we welcome sponsorship. The last area of collaboration is that you collaborate with our group. You can see our group on FerasNaser.com. This is an innovation-based startups group, and we have many projects that require talent and investment. We do have limited budget for innovation and R&D, but also we do have limited access to innovation funding due to our location. So because I am based in Amman, I have really limited access to innovation grants and innovation support. So we can consider new ways of collaboration based on the following fact or based on our portfolio on FerasNaser.com. So that was my presentation for you. I hope you enjoy it, and I'm very happy to take your answers and questions. You will be able to access this presentation on my YouTube channel along with the video, and you will be able to also access the presentation on my website, transportment.com. I will not posting this on FerasNaser.com. I will focus on transportment.com, specifically this publication, but you can see the video on my YouTube channel. I hope you enjoy it, and happy to hear your questions, and hopefully we can answer to the level you expect and even more. Thank you very much.